Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for the instantaneous decoding of conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Guys, today we will see important questions and answers with reference to the engineering geology, which are based on the soil and rock mechanics. Guys, here the question related to the geological and geotechnical engineering or the site selection criteria for the dam site, which is for 6 marks. The question, which is the conceptual point of view, so your answer must have to satisfy that concepts based on the geology and geotechnical engineering. So here the site selection of a suitable dam site, which is the most critical decision in dam planning or in the dam construction activity, where a sound site or the suitable site which must ensure these are all the characteristics through the proper evaluation of geological and geotechnical investigations, that are safety, stability, water tightness, economy and durability. These five components are more useful and essential or necessary for the selection of dam site. That factors are dependent on the geology and geotechnical factors. So here the five geological factors are listed and here the five geotechnical factors are listed. We will see one by one that rock type and nature, structure and its stratification, discontinuities with reference to that rock masses which are available, then permeability and seepage conditions of rock or soil, then weathering and alteration action. So here these are all geological factors which are related to the rock, orientation of rock, types of rock, strength of rock, durability of rock. Likewise, this is the actual expansion of rock mechanics. On other hand, where the geotechnical factors, these are all related to the soil particles and soil with reference to the strength and deformability, with reference to the soil layers, foundation stability, then seepage and uplift pressure, subsoil and overburden conditions, and constructability and material availability. Here, these are all the factors which are related to the soil, type of soil, and its index properties. These two components are characterized by the ideal dam site characteristics, which are these: safety, water tightness, economy, durability, and practical construction or actual construction point of view. So we have to achieve that objective based on focusing towards these geological factors and geotechnical factors. So here the ideal dam site is one where competent low permeability and stable foundation of rock we have to select. We have to ensure that the safety, vital tightness, constructability and economy over the entire life of dam. So dam will be constructed for 100 years or 200 years. So we have to be planned accordingly for their durability with reference to that geological factors and geotechnical factors. So this whole question is of 6 mark. So with reference to that marking scheme, the any three geological factors and any three geotechnical factors that are for 2 marks or 3 or 2 marks. Likewise, the overall objective or conclusion part, which is for 1 mark. Likewise, we have to write the answer for that question. Next question, which is most important and conceptual point of view, based on the reservoir induced seismicity, which is related to the slopes around the reservoirs with the suitable diagrams. Now here we have to explain first the concept of reservoir induced seismicity, that is RIS. What is meant by it? Reservoir induced seismicity, that is the refers to earthquakes triggered by the impoundment of water in a reservoir. Means when the percolated water or seepage water comes in contact with the fault fraction on reactivation area and it causes earthquakes here. So diagram which is most important to extend the mechanism of reservoir induced seismicity, where reservoir is there, dam wall, the whole water which is acting pressure on downward side with reference to the various soil layers or rock layers, and also there are the some rise in pore water pressure or infiltration of water. Likewise, the cracks are noted. So with reference to that fault, the fault reactivation and earthquake will occur. So we have to mark accordingly. Here the mechanism or the process for that reservoir induced seismicity, which is started from impoundment of water, that is increase in reservoir water level, means high flood level or fully filled dam, 100% filled dam. Then increase in stresses, the whole water which is impacting load in the downward direction, which is added load causes increase in vertical stresses. After that, rise in pore water pressure, water infiltrates through joints and fractures in that region. Then reduction in effective stress, effective normal stress on fault planes, which fault planes, and it decreases. Likewise, the infiltration of water will get increases. Then fault reactivation and seismicity, that is shear failure occurs and earthquakes are generated at the bottom of the dam site, so that it shakes the whole nearby soil strata and rock strata, so that the dam wall will get kraken. So what are the silent features of reservoir induced seismicity? They occurs mostly few months to years after impoundment, after fill 100% fill of dam. Then magnitude usually small to moderate, that is less than 6.5, but can be damaging. Most of the events occur at the depth of 2 to 15 kilometer below reservoir. So from that earth surface 2 kilometer to 15 kilometer below, the reservoir seismic induced reservoir induced seismicity will occur, and it may create earthquakes. Second part of the answer, that is the stability of slopes around reservoirs. How we can maintain it, the stability. The stability which is based on the type of rock available and the soil available. Here the fluctuations of reservoir water level and seepage that increase pore water pressure in slope materials, that reduce effective stress and shear strength, leading to slope instability and landslides here in that region. Likewise, so what are the factors affecting that stability point of view? Rise and rapid drawdown of water level, that is rise of water level or drawdown of water level rapidly. This is the actual factor affecting stability. Then second will be the seepage and uplift pressure. Seepage in that region from water comes in contact with the soil or rock layers with reference to the fault plane, fold plane, cracks, everything. Then saturation of weak and strengthened or weathered materials, adverse structural features like joints, bedding, faults with daylightning. Likewise concepts where we see the cracks are there, seepage and rise in pore water pressure will be noted by the blue color dotted line. Then reduced shear strength is also noted. Stresses are acting from downward direction. Likewise, so here when driving forces that are from weight, seepage, water level fluctuation are more with reference to resisting forces that are shear strength along the slip surface, then the result is slope becomes unstable and failure occurs. So here the result, disturbance of stress equilibrium to the fault slips, and then earthquake will occur at the fault reactivation below to the bottom of the dam, that is 2 kilometer to 15 kilometer away. So here the stability improvement measures are followed with reference to maintain control rate of filling and drawdown, provide adequate drainage and relief walls, flatten slopes or benching, and surface protection and vegetative cover point of view. So that all actions increase the slopes stability around the reservoir and all the things. So here the impounded reservoirs or fully filled reservoirs can trigger earthquakes by altering stress and pore pressure at the and that can also reduce slope stability due to seepage and water level fluctuations continuously. Here the proper planning is most important. Monitoring and mitigation techniques we have to implement, and they are more essential for safe reservoir projects. So we have to maintain a safety for that reservoir, so that we have to ensure that the reservoir induced seismicity and the stability of slopes around the reservoir, means we can use the whole area below in the upstream side of the dam wall for the storage of water. Otherwise that store water may get percolated, or the landslides may occur within the catchment area. So your answer having that all steps or particulars based on the explanation here. Your diagram is most important for that question. Then most important point related to the geology in disaster risk reduction. So here the question for 6 marks, it will be framed based on some application or the comparison point of view. Here we have to discuss the role of engineering geology in disaster risk reduction and geohazard management. So two parts, risk and geohazard. Here the role of engineering geology, which is most important for each and every construction activity point of view. Here, the engineering geology applies geological knowledge and techniques to understand, predict, and manage geohazards, thereby reducing disaster risk and enhancing community resilience and sustainable development. Means we have to provide the safety to all the society with reference to engineering geology constraint. Here, that hazards or that role of engineering geology is divided into six various characteristics related to the hazard identification and its assessment, risk analysis and zonation or marking of risk zone, then mitigation and management measures, early warning and monitoring point of view, capacity building and awareness creation, policy planning and sustainable development. So here the actual work which will be followed by the engineers and the policy which will be framed with reference to the activity completed or the experience noted, that is the actual role of engineering with reference to the disaster risk reduction. So here the role in disaster risk reduction and the geohazard management which will be followed the procedure with data collection and investigation, that data of the field studies including mapping, drilling, sampling, remote sensing, GIS with reference to the ground control points. Then hazard identification and assessment, we have to identify that geohazard and we have to assess that hazard based on some likelihood, magnitude and impact of that hazard on the nearby society or the area. Then we have to analyze that risk and we have to mark the risk zone on the basis of vulnerability and preparedness of the hazard with reference to that risk zone maps. After that, we have to mitigate and manage the planning, or we have to prepare to satisfy the risk analysis and zonation based on some mitigation techniques. Then design and implementation of structural and non-structural mitigation measures are followed. After that, the monitoring of early warning and response based on some continuous monitoring, that will be threshold alerts, execution, excavation, evacuation and emergency response provided to all other society or the peoples who are living in that area, which will be aimed at the review, capacity building and improvement, which will be the post event evaluation, learning awareness and plan improvement. So this is the actual process which is followed for the role of engineering geology in the disaster risk reduction point of view, or we can say that the geohazard management point of view. So here the question answer must have to satisfy these all procedures. The outcome which will be based on the reduced risk, minimize losses and resilient communities or societies with the sustainable development. So here most important, engineering geology bridges geology and engineering gap to foresee geohazards, reduce risk and build a safety, more resilient society through science-based planning, mitigation and community preparedness. That is the actual essential objective or conclusion for that question. So this type of answer which is most likely to have to be right with the exam point of view with reference to that short marking scheme for the 6 marks. Stay tuned guys. Happy learning.